Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Okay, so Alhamdulillah we get back to our SolidWorks projects on the glass suction cup mount holder. So previously we have done the gear connector, the left and the right, and certain component in this project. So for this video session I would like to show you this component, which kind of we have a ring here, a cylinder, and we have a lever here. So this component behave as a tightener. So this component will be mounted on this column here, a cylindrical column. So it's not quite that clear in this images. It will be put in this mount here. So we have a column here, so it behave that we have a pin. This pin will be put if we in this groove. So this pin will be attached to this slot here. So you will get I don't want to explain more about actually the detail of it. So actually inshallah in our next video session when we assemble it, so maybe I can show you how the function of this part. So actually this component is behave as a tightener, where it can push the suction cup downward toward the surface, so it will create a vacuum, so it will be stick on the surface, on the glass surface. So the clear picture of this component is can be shown in this image. So this is a bigger image. This component we can call this component, you can call it as a what we call it tightener or something else. So if you study this component here, we have a cylindrical shape, a hollow cylinder, and we have a structure here. It's a lever. So in order for us in SolidWorks, for us to do this kind of modeling, so for this part it shouldn't be problem. This the most trickiest part is this component here. So we start on this component. See, so we have a base point at the center of the cylinder, so we can do a cylinder extrude. But the tricky part, if you look, the hardest part is for us to do this kind of geometrical shape. If you look on this cylindrical, so we have a kind of involute or something, a kind of curvature here. We have a curvature that is repeated twice. So we have a flat surface here, we have a groove downward, so we have a curvature upward, so we have a little bit groove where the pin will stop here. Actually the pin will initial position in will be mount on this groove. So when we twist, when we turn this knob here, so it will be moved, the pin will be moved, and it will be staying on this position, on this smaller groove. So it will lock and position in this position. So the repeated curve, if you look, there's a repeated curve. We have flat surface in a groove, then we goes upward, then we step downward, flat surface, this flat surface here, and this flat surface is the same thing, is repeated. We have in a groove, then the curvature go upward, so we have flat surface here, then we have a smaller groove here. So it will be kind of a repeating process. So in the SolidWorks, for us to do this kind of geometrical, we cannot do subtract, we cannot do cut extrude on the cylinder on this, because since the surface of the cylinder is curvature, if we put the flat plane here and we cut extrude, so it should be a problem for us to do this in a groove. But for this curvature upward is quite difficult, because curvature is flow on this direction, but for this curvature it flow on that direction. So one way, I think is the best way in SolidWorks to do this, is to use wrap. There's a wrap, W-R-A-P, wrap command in SolidWorks. So in wrap command, so the function of wrap is that we have, since as long as we know the diameter of the cylinder, we can use a profile. If we unwrap the shape of this profile, so it become kind of pattern. Yeah, as long if you draw the pattern, we have lines step up, a groove, then we have curvature upward, flat surface, step down, then a groove. So we know the profile, the shape of this geometry. So when we unwrap it, so we know the pattern of it, so we draw the pattern, then we wrap it around the cylinder, so we can form this kind of geometry. So as long so the idea is that we know the diameter, so you must draw the profile, the pattern, the total length. The length of this pattern, total length, is a perimeter of the diameter of the cylinder, where perimeter is what, pi times the diameter. So I'll show you the finished part I've done. Let me exit this part. Okay, if we look until the finish, okay, takes time for my computer to reload. So this is the finished part. So this is what I've done in SolidWorks. So the components, so if you look, we have the slot here, the curvature, upward, step down, flat surface, downward, groove. We have a groove, then upward, flat surface, downward, flat surface. There's a groove. Okay, so what I did is I use wrap command, so it will wrap around the cylinder to form this thickness. Then I subtract it by using the inner diameter to extrude cut to form the hollow cylinder. Okay, let me show you my starting point. Okay, at the beginning. Okay, at the beginning, the first thing what I did is I have box extrude. Okay, if you look on this smaller cylinder, the smaller cylinder here is actually the inner diameter of the cylinder. So yeah, for us to do that, we make the smaller diameter the inner cylinder, then later on, then only I cut extrude to form the hollow. Okay, so what I did is the inner diameter, since I know the inner diameter, the radius is 16, then we extrude the height. The height is about the total height. The total height is 8. Okay, we extrude it. The total height is 8. Then if you look, we have the dimension here. Okay, the diameter is 16 and the height is 8. Okay, the height is 8. Okay, then I use a wrap command. So until I got this kind of geometry by using wrap. Okay, let me show you how I did it by using wrap command. So let me show you the profile of my sketches for me to do wrap. If I go to normal view, as you can see, we have this, our pattern, our profile shape. If you look, it's a repeating pattern. So we have a groove here, then the curvature upward. We have flat surface downward. We have a flat line here, then a groove, then a curvature upward. So if you look, in order for you to do wrap, make sure that our rectangular portion here must be starting at the origin of the cylinder. So the SolidWorks will do the calculation. It will wrap it around the cylinder. And also the construction shape here. So if you look, the total length of this rectangular section for our pattern to wrap around the cylinder, so the total length must be the perimeter of the cylinder, the perimeter, which pi times the diameter of the cylinder. If you look on the dimension, we have a symbol here. The symbol in this dimension here means that we have do some variables in the dimension of the cylinder. Okay, let me show you how in SolidWorks we can replace our dimension by using variables, so it's easy for us to do our settings. So since our length of this rectangular section is pi times the diameter of the cylinder, sometimes we couldn't remember the what's the exact value of the diameter, so we use the variables name pi times the, in my case I use diameter 1 as a variable for this cylinder, so the perimeter is pi times diameter 1. So okay, let me show you an example how I do it in for this part. Okay, let us open a new file. This is an example. Okay, we start it from the top plane and we do sketch plane. Okay, let's make a quick circular shape here. Then we put a dimension of, since the inner diameter is 16, then I put in 16. I'm sorry for my I'm using my old laptop, very old laptop, so it takes memory, CPU and memory to do this video session. Alright, see this diameter, so let me go to isometric view, then we do some extrude. The height of the cylinder is 8. Okay, the height of the cylinder is 8. Okay, we have some extrusion. So before that, if I go back to this sketch, I could replace the diameter 6 here. If I did this edit the sketch, okay, the diameter of the cylinder is 16, so if I replace it, if I double click on it, so in this dialog box, instead of using 16, I type it equal to. When you type equal in your dimension settings here, dimension value, so if I type equal, it become variable, so I label it's equal 16, diameter 16 is equal to, I label this as diameter 1, so it become variable. So SolidWorks will pop up, you can create a new global variable name diameter. I click yes, so it become a variable name diameter 1, so it means 16 is equal to diameter 1. So we have a symbol here. So, okay, so let me exit my sketch. So we have our cylinder. So the next step, what we do, we go to the front plane. It should be on the front plane for us to do wrap. So I make a sketch on this front plane and go to normal view. Go to normal view. So what we do is we make a rectangular shape here, a rectangle for us to do our profile, for us to do wrap. Okay, so make sure that for you to do wrap, for you to do rectangular in your rectangular here, so you have to make sure that the starting point of the rectangle should start on the origin of the cylinder. So, and the height should be the total height of the cylinder. Let me put anyway at this point for the length. Okay, if you put the dimension here, the length of our rectangle area here should be, the length is a perimeter of the diameter, so it should be type equal. When you type equal here, okay, you type equal pi times, because since I label the diameter is diameter 1 times diameter 1, so diameter 1 is equal to 16. So you type OK, so the length will be 50.27. So we also have the symbol here, so it means that we have put it into variable, so pi times diameter 1. Okay, so this will be the perimeter of the cylinder. Okay, the next thing what you should do before you draw your profile shape here, you should convert the rectangular area here, the rectangle here, into construction geometry, so we know our boundary. So you convert it to construction geometry. Okay, then you can draw. Now you can draw the profile of your shape, so it will be wrapped around the cylinder. So let us okay, let me show you. We draw the profile shape. So let me start by doing line. So we started by line. Make sure the snap, don't snap at the middle point, you snap at somewhere around here. We have a flat line. Okay, let me check. Okay, we have a flat line here. Okay, then we have a, you press A, then you can do a semicircle. Then we stop it there. So we do the option here. We have 3-point arc, so I start at this point, and my end point is somewhere around here. Then I drag a little bit. Okay, then we do line here. At this point we have a flat line here. Then we have a step down. Then we have a flat line. Then we have another arch here. And okay, I do another 3-point arc there. Ending is here. We drag like that. So okay, we have a line here to this point, to this point, to this point, to this point, until it closes the loop. So make sure that you don't have opening. You don't have opening, you have a close shape. Okay. Okay, the trickiest part is for you to set a constraint, put a dimension, as can be shown in these images. We have a certain diameter, like the height here. But in this, the way I've done it, so I started differently. So I had start from the groove, the curve, step down, flat line, a groove. We have a here, then it's repeated by this way. But in for the example, I show you. I started from the flat line here. Okay, so we have the dimension 5 here, and the length is 8. Okay, let me do that. This example. So we can, for example, I show you a constraint here. So for example, that this line and this line is a constraint here. So we select this line. This line we set a relationship tangent, and also from this line and this line we also set it tangent, and same goes here, this line and that line tangent, and also this line and this line tangent. Okay, the dimension is 5. Okay, the total height is 8, and so we know the dimension here is 8. Okay, I can set another constraint. I set another relation. This line and this line is equal. So you can collinear. So the height is 5 and also equal. So the total length will be this one also. The length is also will be 8. Okay. Okay. Let me finish set the constraint and the dimensioning here. So I'll be I show you on the next session. Let me finish the constraint here. Okay, so this is our finished sketch with constraint or relationship. Okay, then our next step is to do wrap command. We do wrap command. We can get the wrap command also. Let me exit the sketch. So we have our profile, so the length here is a perimeter of this diameter. So we have our profile, make sure the profile is a closed shape. Okay, then we use wrap command. So the wrap command, you can use wrap under this toolbar, or we can use under pull down menu. We have features, we have wrap. Okay, it's the same thing, wrap, or you can use the toolbar here, wrap. When you do wrap, so the first thing you select the plane, the sketch contour. So you select the sketch contour to be wrapped. So we have the wrap setting here. Either we can use emboss, deboss, or scribe. So in this case, I show you emboss. Okay, emboss is when the wrap pattern here will be wrapped around the cylinder, so emboss will going outward instead of inward. Emboss it. Okay, so right. So the area is for us to select the face where we want to wrap. So in this case, is our vertical cylinder here. Okay, our vertical cylinder. So if you look, it already show you the preview where our pattern will be wrapped on this cylindrical surface. So the thickness, so here is the thickness, so the thickness of our wrap. So it will give, so the thickness is 3. If I click OK, so we have our surface is wrapped around the cylinder and embossed outward. The thickness is 3. The thickness is 3 in the thickness here is 3. Okay, the thickness here is 3. Okay, let me go back to my SolidWorks. Okay, isometric view, thickness is 3. Since we don't want this inner cylinder, so we can cut it by using cut extrude. Okay, we can cut it by using. So we have if you look on the profile, so we have a flat surface, we have a groove, then we have a curvature. Let me put you on the right view. So you'll be repeated. We have a curvature, and it go down to a flat surface. At the bottom we have a groove, then it will the curvature go upward. So we have, so we can do this kind of geometry as shown here. Okay, right. Let me go back to, okay, my computer is running slow. Let me go back to isometric view. So the next step, if we cut this thing, so I select this surface, make a sketch plane there, do a circle, and make sure it snap to the edge. So the diameter, so diameter is 8, so the radius is 8, diameter is 16, so we do extrude cut. Make sure we go through all. So we have our this part of this component. Okay, so for the time being, I end at this part. So inshallah, I will continue on the next part for the lever, this part, how we do it in SolidWorks. Okay, inshallah, I will do it on the next video session. Okay, thank you very much for your listening. Assalamualaikum warahmatullahi ta'ala wabarakatuh.